Hi, Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to all my students. Okay, so this is the session of tutorial for topic 5 with a date of October 19, 2020. So I do hope that all of you all enjoy your moment with your family. Okay. So then I'll share with all of you or discuss a few questions from the topic of 5 tutorial, and I do hope that all of you may continue the rest of the questions. I'm not going to discuss all. So for this one, I begin with the topic 5 tutorial, page 54. Okay, so question number 3, I'm not going to discuss question number 1 and 2. Okay, so I do hope that all of you just look at the pictures and try to understand. Okay, sketch the functions below, states, domain, and range. I think that if I come up with one example for question number 1. Okay, for question number 1, example here. So let's say if I have a function of fx equal to x squared minus 2x minus 8. Okay, so from here we can factorize this with x and also x. Okay, so this is a product of root with a pairing of 1 multiplied with an 8, 2 times 4, 3, 4, 4 with 2, 5, no, 6 and 8. Okay, so there are only 2 possibilities of multiplication with result of 8. 1 times 8 and 2 times 4. But then let's take a look at this one here. Sum of root. This is a product multiplication, product of root, and this is sum of root with negative 2. So we can imagine that this is the most suitable one, 2 with 4. So because the difference here is negative 2, it's just like negative 4 plus 2. 1 minus 8 is not equal to negative 2, and negative 8 or 8 minus 1, it cannot be equal to negative 2. So this is we call the best pairing here, which means that it's come out with x plus 2 and x minus 4. Okay, so means that here if we make this one as an equal to 0, fx equal to 0 with x squared minus 2x minus 8. Okay, sorry. Okay, so this is an x-axis and also y-axis. From here, we can make a conclusion that when fx or y equal to 0, then y equal to 0, then x equal to negative 2 or x equal to 4. Okay, where is the coordinate of negative 2, 0 and 4, 0? Okay, because when x equal to negative 2, y equal to 0, and x equal to 4, y equal to 0. So this is the coordinate negative 2, 0 and 4, 0. Okay, when y equal to 0, this is the coordinate on x-axis. So we got negative 2 here and 4 here. Okay, and this is quadratic, x squared, so it's either the graph of smile or sad, the graph with a minimum point and maximum point. Okay, so then we are going to find out if Okay, for example, ax square plus bx plus c. This is for a positive, and this is when a is negative. The coefficient of x squared for this question is 1, which means that we're talking about this. A is positive, so we got the minimum point. So we are going to find the minimum point here. Okay, so from x squared minus 2x minus 8 equal to x squared minus 2x plus negative 2 divided by 2 square minus negative 2 divided by 2 square minus 8. Okay, from these three, negative 2 divided by 2 equal to negative 1. So we factorize as an x minus 1 square, and then minus negative 2 divided by 2, negative 1. Negative 1 square is 1, minus 1 minus 8. So then you come up with x minus 1 square minus 9. So from here, we can make a conclusion that when x equal to 1, then y equal to negative 9. So this is the coordinate of minimum point. Okay, now, so we just imagine that if the x negative 1, negative 1, negative 9, so x equal to 1 here, and somewhere around here, negative 9. So if I in color with this, so the graph will be something like this. Okay, cross the 2 here, then this is the point. Okay, sorry. Okay, something like this. The graph should be smooth, something like this, but I do hope that all of you can sketch it nicely then on your paper. Okay, so this is the minimum point, minimum point of 1 and negative 9. This is the coordinate of we call 4, 0, and this is the coordinate of negative 2, 0. Okay, so class, the distance from negative 2 to 1, which is 3 units. Okay, from 1 to negative 2 is 3 units to the left, and 1 to 4 is also 3 units to the right, meaning that this is the middle point between negative 2 and 4. Okay, now, class, look at this one here now. The domain and range of this function. Okay, the domain and range of this function, if we refer, or we refer this graph to the x-axis. Okay, we refer all this to the x-axis. It seems like all the values of x are the domain of this function. Okay, so it's just like it's all the values of x is the domain of this function. Okay, and what about the range of function here? What about the range of the function? Okay, look at this one here. We refer to the y-axis, and this is all the values of y that being mapped from the graph of the function. Okay, until the lowest point, which is negative 9 here. So, means that all these are the range of function f, or the value of y, from for the top here until y equal to -9. Okay, so we can make a conclusion that from this from this explanation, the domain of this function equal to -infinity to +infinity, or we can also state it as an all real numbers, positive and negative, and the range of this function equal to from positive infinity, then the lowest point is -9, so it means that is from -9 to positive infinity. Okay. This we call the introduction or the beginning of the discussion. I'm sorry if all the written is look very messy, but I hope all of you can follow it. Okay, now let's take a look at question number 3. Question number 3a. Okay, the question wants us to find the domain and range of the function and sketch the graph. And sketch the graph. Okay, the question of number 3, page 54. Okay, so I'll choose the first example then here. Fx equal to 1 minus x, and written there for x which is less than or equal to, x less than or equal to 1. Okay, I read the question again. If you refer to your tutorial book, page 54, question number 3, find the domain and range of each of the following functions and sketch the graph. So then, okay, now, let's say if I erase this for a while. Okay, I erase this for a while. Let's refer to the function itself. Okay, 1 minus x. So then, the first one here, okay, so this is a linear. Let's say for linear function means that a straight line. Okay, straight line, you have two methods. Okay, two methods or idea. Idea number 1, you can choose any two values of x. Okay, that's the first idea. Okay, how is it? Okay, now let's say if I say when x equal to 0. So just imagine that if I substitute x with 0 here, so then y equal to 1 minus x. So when x equal to 0, y equal to 1 minus 0 equal to 1. And when x equal to 1, so 1 minus 1 equal to 0. Okay, so means that we have two coordinates of 0 and 1 with 0. Okay, that's option number 1. So 0 and 1, 0, y equal to 1 is somewhere around here, and also 1, 0 is here. So you sketch the line of the graph of y equal to 1 minus x. That is the first idea. Second idea, okay, you may choose either one which you prefer then. Second idea is, let's say, when x equal to 0, then y equal to 1 minus 0 equal to 1. And we call 1 minus 0 equal to 1. So when x equal to 0, y equal to 1. And when y equal to 0. So look at this one here now. First, we choose any two values of x, x0, x1. Second idea, or second method is, we first assume that x equal to 0. Second is, when y equal to 0. So when y equal to 0, just imagine that y equal to 1 minus x. So 1 minus x equal to y, which is y equal to 0, negative x equal to negative 1, then x equal to 1. Okay, so what about this one here now? If I sketch another, we call x and y axis. So then this is a coordinate of x equal to 1, y equal to 0. Okay, when x equal to 0, when x equal to 0 means that the coordinate is on y axis. Again, I repeat, when the value of x equal to 0, meaning that it's a coordinate, it lies on x axis, which is 0, 1 here. And when y equal to 0, the graph intersect at x axis here. So see, you will get exactly the same graph as this one, the earliest one, with a different method. When idiom number 1, choose any two values of x, you get it here, and then you plot on the graph at x and y axis, then you make a line, or you put it different ways. When x equal to 0, then you get the value of y, and when y equal to 0, then find the value of x. So you get two different coordinates here. Plot on the graph on the x and y axis and make a line of this one. So y equal to 1 minus x. Okay, back to the question then here, fx equal to 1 minus x. So if fx equal to 1 minus x, okay, I'm sorry again. It's different for me to make a straight line. Okay, this is y and also x. Okay, now just now we found that it's a coordinate, because this is kind of line here, one graph here, 1 and also 1. Okay, then this is the straight line or the graph of 1 minus x. Okay, this is the graph of 1 minus x when we call the values of x are all real numbers, is either negative or positive. Okay, but then when we limit the values of x according to the question is for x less than or equal to 1. So when x less than or equal to 1, just imagine that this number line, the 1 here, so the value of x less than or equal to 1. Okay, so it started here from x less than or equal to 1. So which graph that we wanted from this question here? From this point to the left side, meaning We are talking about the graph of the graph of this. The graph of this on the red, we call the red ink here. And we may erase the rest of it. There you go. So can you see the graph of 1 minus x? Fx equal to 1 minus x for x less than or equal to 1. Just now, it's a straight line. Cross this line of x-axis, x equal to 1 until down here. But when we limit the domain, so it's begin from x equal to 1 to left side, x less than, all negative values in here. So it means that the graph is just half of it without this part here. Okay, so then let's find out the domain of this function and also range. Okay, so the domain of this function, so look at this one here now. We refer to the x-axis. Okay, we refer to the x-axis and it's all here. Okay, class. For this question, you may refer the domain based on the picture of this graph, where is all the values of x from 1 to negative infinity, or actually that this is the answer of the domain. Automatically, if they give you the function of fx equal to 1 minus x, x less than or equal to 1, this is automatically the domain of the function, which is from 1, okay, from negative infinity to 1. And then, what about the range of this function? Range, we refer to the value of y. Okay, so we look at this graph here and find that this graph mapped to the y-axis along this here, okay, along this line until here. So, what is our conclusion then? It started from 0, y equal to 0, to positive infinity. Do you find any graph below the x-axis here? Below the x or y negative here? No, right? So this is the answer then. Okay, next, the function of fx equal to x squared minus 5, and then for x less than or equal to 0. Okay, let's ignore or hide this first. Okay, so from here, this one, okay, when x equal to 0, y equal to negative 5. Okay, so for this graph, when x equal to 0, y equal to negative 5. And when y equal to 0 or fx, x squared minus 5 equal to 0. When the fx or y equal to 0, then this one come out with x minus square root of 5, x plus square root of 5 equal to 0. So then x equal to plus minus square root of 5. Okay, so now square root of 5, you may just find out, or you call the value of that using calculator for decimal. Let's say if I put this one here as a negative, Okay, negative square root of 2, and here is square root of 2, and this is negative 5. Okay, the coefficient of x squared, this is 1. 1 we consider as an a equal to 1, which is greater than 0, then the graph will be assigned what we call smile graph here. Okay, never mind. So let's say if I sketch Bismillahirrahmanirrahim. Okay, something like this. There you go. Okay, that's it. Something like that. Okay, it's not exactly something like this one here. It's more something that we call a curve, but never mind. You may use any apps from your phone just to see the real picture of this graph. Okay, now this is the graph of x squared minus 5 if x is all real numbers. Okay, if x is all real numbers. But at this time, we give you, look at the question again. For question number 3b, page 54, your tutorial book, is 4x less than or equal to 0. If x less than or equal to 0 means that x0 start from here and x less than or equal. So when x less than or equal means which graph that we wanted, which graph that we're talking about, including this part, x greater less than or equal. So means that it begin from here. Okay. There you go. So what about this graph? Let's erase this. Can you see now? The graph on the left side is the answer for this question with the value of x4 less than or equal to 0. Okay, you sketch it nicely with on your paper. Okay, something like that. So now let's find out the domain and range of this function. As I said that this is the domain of the graph. So we may just copy out the answers here. It's begin from negative infinity until 0. And what is the range? Range is all values of y. So look at this one here. It's all mapped to the y-axis. Okay, mapped to the y-axis. Begin from negative 5 to positive infinity. So the answer is the range is from negative 5 to positive infinity. Is all values of y and this all values of x. Okay. Let me choose one of the questions from question number 4. Okay, the question from question number 4. Qx, the function of Qx equal to square root of 2x plus 6. Okay. Do you find any values of x stated here? Nope. Meaning, okay, the question wants us to find, the question said determine domain and range of the following function. So find the domain of the function and also the range of the function without telling us what is the range of, what is the value of x, meaning that we need to clarify the domain first. Okay, now, class, square root of 9 that we can simplify as 3 here. Square root of 4 equal to 2. Square root of 0 equal to 0. But when it comes to square root of negative 4, then this come out with 2i. So this is how we call an imaginary part. Imaginary part or imaginary numbers. We are now talking about real numbers, okay, all real numbers here. So it means that this is not part of the answers for our questions here. So from this, and this example, that we can make a conclusion that the function of qx exists when 2x plus 6 greater than or at least equal to 0. Okay, so then from here, 2x greater than or equal to negative 6 and x greater than or equal to negative 3. So then class, automatically this is the domain of this function qx. Okay, x greater than or equal to negative 3. So it begins from here, negative 3. Okay, and x greater than or equal means that from here, it moved to the left or right. Yes, it moved to the right. And this kind of graph, function of fx equal to square root of gx. For this one here, the graph, the graph will be something like this. Okay, from here, there you go. Okay, so then from this point of negative 3, okay, let's say x equal to negative 2. Negative 2 times 2 equal to negative 4. Negative 4 plus 6 equal to 2. Square root of 2 is positive. When x equal to negative 1, negative 1 times 2 is equal to negative 2 plus 6 equal to 4. Square root of 4 equal to 2, positive. When x or so on, well, let's say x equal to 4 here, 4 times 2 equal to 8. 8 plus 16 plus 6 equal to 14. Square root of 14 equal to a decimal number, something here. So the graph will be something like this. Sorry. Okay, the graph will be something like this. Okay, so now, what is the domain of this function? The domain from negative 3 to positive infinity. Negative 3. Negative 3 with this symbol means that it is include negative 3. Okay, to positive infinity. And the range of this function, okay, we refer to the value of y, to the y-axis, starting from here, y equal to 0, and all the values of y above the x-axis, meaning that the value of y which is positive. Above the x is all the value of y which is positive here. So then, the range equal to 0 to positive infinity. Okay. So the question says, determine the domain and range of the following functions. Okay. I'll choose question number 4C. Again, the question determine the domain and range of the following functions. Okay, now the question given to us here, the function of Sx equal to modulus of 5 minus 2x. Okay, just ignore about this sign of absolute values here. So just imagine that if we only have as x equal to 5 minus 2x. Okay, so then we use the idea of when x equal to 0, so y equal to 2 times 0 here. 2 times 0 equal to 0. 5 minus 0 equal to 5. And then when y equal to 0, when y equal to 0, 5 minus 2x equal to 0, negative 2x equal to negative 5, then x equal to 5 over 2. Okay, so let's find out now the coordinate of these 2 points. Sorry. Okay. No. There you go. Okay. So then y and x. Okay, when x equal to 0, y equal to 5 means that this is the coordinate of 0 and 5. 0 and 5. Okay, when x equal to 0, the coordinate lies on the y-axis. This is where 5 here. 0 and 5. And then for this one here, when y equal to 0, so the coordinate of 5 over 2 and 0. When y equal to 0, then the coordinates lies on x-axis, which is 5 over 2. There you go. Okay, so then let's sketch the graph of this. Maybe something like this. Okay. Okay, never mind. We make some adjustment from here that this is 5 and this is 5 over 2, somewhere around here. So this is 5 and this is 5 of 2. Okay, now this is the graph of 5 minus 2x. Let's get back to the original question here. We're talking about the function of Sx equal to modulus of 5 minus 2x. Modulus means that the graph is always positive for all values of x. So, the graph is always positive for all values of x. It means that the line that below x-axis, which is here, will reflect above up to x-axis, something like this. Okay, and the rest of it all here. Okay, so the graph for this function of this question, the modulus of 5 minus 2x is all the graph, okay, sketched by the red ink. So then I'm going to erase the graph with the blue ink here. There you go. Okay, don't make this kind of lousy graph in your lecture notes or your exam recall, your papers. Sketch nicely, because I can't sketch nicely using this and also the wizard pen. We call the board here. Okay, so the graph will be something like this here. Okay, at point of this and then move up. So now what is the domain of this function? So then the domain of this function is all values of x. All values of x, because the graph is unlimited. Okay, there's no end. So means that the graph for values of x, the domain, are all real numbers. Okay, are all real numbers. Or we may also write this one as a negative infinity to positive infinity, all real numbers. And the range of this function, range we refer to the y-axis. Okay, we refer to the y-axis. As you can see here, there is no graph below the x, meaning there is no range for y negative. So means that here the range is 0 to positive infinity. Okay. And composite function, we move to the next subtopic. Okay, sorry. Okay. I had used all the page, 10 pages of this slide. If I add up with one or two examples of composite function. Okay, composite function. Okay, page 55. So question number I choose one only for question 8. Okay, to end our session for this afternoon. Okay, given the function of fx equal to 2x minus 1, gx equal to 3 minus 2x, and hx equal to 1 over 4 5 minus x. Okay, so composite function, find kx, where kx equal to fgx. Okay, the first question here, they get given then kx equal to fgx. So find kx. Okay, so if that's so, we are going to combine these two, composite of between f and g, to find the value of kx. So gx 3 minus 2x, and substitute whole function of 3 minus 2x into an x of the function f. 2 3 minus 2x minus 1. Okay, 2 times 3 equal to 6 minus 2 times 2x, 4x minus 1. 6 minus 1 equal to 5 minus 4x. There you go. Okay, question B. Question B, find h kx. So kx we get from the first question here, 5 minus 4x, and h is all here. So h 5 minus 4x, and substitute the whole function of this into an x of the function h. So then it come out with 1 over 4 and 5 minus x, x with 5 minus 4x. Okay. So 1 over 4, 5 times negative times positive, minus 5, negative times negative, positive 4x, 5 minus 5 equal to 0. So you come up with 1 over 4 times 4x, so then equal to nx. So this question C, what is the relation between the function h and k? So the question C, what is the relation between the function of hx and kx? Class, when two functions be combined or composite between the function of, for example, h and k, when it end up with the result of x. Okay, when the composite between two functions end up with the result of x, something like this one here, so we can come up with a conclusion that kx is an inverse of the function to the function of kx is an inverse to the function of hx. Okay, so I do hope that a few examples of the beginning of this topic tutorial of chapter 5 helps you to continue with the rest of the question. And that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Enjoy your weekend. Now enjoy your week. Stay at home then. Okay. Thank you very much.